My name is Wilfred Abincha. I'm going to take you through this tutorial. Kindly subscribe, like. I want to talk on how to analyze data that is generated using augmented design. In case you want to get more clarification from me, you can write me an email using this email here. The augmented design is used when the researcher does not have enough materials to replicate, or when the research has a lot of materials that he or she cannot handle with the few resources that are available. Therefore, in such cases, we resort to use augmented design. Here I have two data sets. I have this one and this one. So I'm going to use this one for this analysis. That's why I've imported here. Let me run this and let us view this data. I've called it dat1. Yes. When you want to analyze your data which you planted in using augmented design, you arrange your data into blocks and genotype all treatments, then your traits. One key feature of augmented design is that in every block we have checks that are replicated. What I mean is that in block 1 we have checks, and the same checks appear in block 2, and same checks appear in block 3, and so on and so forth. For instance, here in block 1 we have 5 genotypes from here to here, and these 5 genotypes, 3 of them are checks. Like here, this one is a check, this one is a check, and this one is a check. If we come to block number 2, we have this one is a check, this one is a check, and this one is a check. And this repeats throughout the number of blocks in this experiment. Therefore, in this experiment, a block has 5 treatments, and out of 5, 3 are checks. That's how augmented design is arranged. So let's go back. For you to do analysis using this design, you install this package called Augmented RCP. I have already installed this, so I'm not going to install. Then we look at the structure of this data. So we can see here in the console that the block and the genotype are not factors. They are supposed to be factors. So we have to convert them into factors. So to convert this block and the genotypes into factors, we use as.factor command. So you write this column, block and genotype, the block column in dat1, and this is genotype column in dat1. You write as dot factor, then you write again the column that you want to convert into brackets, then we run this. That's been executed. Then we recheck to see if the execution was done. Here you can see the block and the genotypes, they are factors. We are okay. So the next thing we do, you have to load this package augmented RCPD into your library. That you write library augmented design like this. You run. So after it has been loaded, I think it's loading. You can see this red means it's loading. It's taking some time. It's finished loading. Then there are two ways that we can carry out our augmented design analysis. So the first The first way is to handle one explanatory variable at a time. That's looking at one trait. You can see you can look these traits one at a time. You analyze DMC, this and this one at a time. And the second is to handle all those traits at a go. You analyze them at a go. So we have to first see how to analyze this data using one explanatory variable at a go. Let's call it out1. It's out1. Then you write your package augmented RCPD. The first thing you do is you write the first column of your data. It's called that one block. See the way we arrange them. That's one block. So it's here that one block because our data we call it that one. If you remember up here, that one. So you write that one blocks the first column, followed by the second column of treatment with genotype. You write that one genotype as we arranged it here. That one genotype is our treatment, and you write now the trait. The first trait we are looking at is that one DMC. You can see DMC is here. That one DMC, and you specify the method of comparison that you want to compare these materials. Here I've put LSD. You can choose to put Tukey or all those others. Method of mean separation methods. Compare your materials. You specify that we have to group our materials. You say it is true, group is true, and then you write your checks. Checks, we have three checks as I said. You write C, then we have this check, and this check. These are the checks which are repeating in all blocks. So you put these checks as because there are many. You write C, you put it this way, checks. This alpha level that you want to use, this being a field experiment, 0.05 is okay. Then console, we say true. Console means that this hour can be printed down here in the console. After doing this, we run. Now this is the results here down in the console. We have our results here in the console. We have done our augmented design analysis, and this is the information number of blocks we have in our experience. There we have 5 blocks. Number of treatments there are 13. Number of checks there are 3. Number of test treatment is 10. What it means is that the total treatment is 13, and in this total treatment we have 3 checks. Therefore, what's remaining is 10 test treatment. And here we have our ANOVA for adjustment treatments. Here, you can see there's nothing which was significant there from here. And you can use also this block adjusted ANOVA. See, mostly people use this block adjusted. So here we don't have any significant difference. Okay, this is how we do it with one trait. Now let's look at how can you do it if you have more traits. This one we call it out, our analysis. You write augmented RCPD, but now dot bulk. This bulk means you are going to handle many traits at a time. So you write, previously we wrote augmented design, augmented RCPD, but now we are going to write augmented RCPD dot bulk. You specify your data. We are using that one as our data. Blocks, our blocks, we name them as blocks, capital B. So your block is blocks. Yeah. Treatment, the second column has to be treatment here. So treatment is genotype. Treatment is equals to genotype, the way we have written it here. Genotype. Then traits. We're looking the three traits as to go. You write traits because there are three. You write C, open brackets, write all the three traits. This trait 1, 2, severity.cmd. Where the space here, you put full stop. Severity.cbsd. After finishing writing our three traits, we specify the checks because there are three also. See, you write your checks you have here. Check color. When we are going to do frequency distribution, R will differentiate checks from other material using color. So you write check color. The first check will be color brown, the second dark cyan, and the third check for forest green. We have three checks, therefore you have to write three different colors. So this KEN7 will take brown, UKMZ26 will take this, and MF007 will take this. So that's check color. Then you put your alpha level that you want, 0.05. We want a description, descriptive statistics. You write describe equals true to give us the descriptive statistics. Frequency distribution, we want them, you say true. GVA is genetic variance analysis. We want it true. Console, yes, we need it to be printed in our console, right? True. Then we run this. Running. Here, it's done. So if we come up here, augmented design, you can see details right here. So ANOVA treatment adjusted, ANOVA treatment adjusted. It is here. These are the degree of freedom here. DMC. See here, it's not significant. You see a lot of things are not significant in DMC. Severity of CPSD is here. You can see treatment was significant. Genotypes. Severity of CMD is here. Then we can see, we can look here at block adjusted. Block adjusted, you can see DMC as usual, not significant here in this case. Severity of CPSD, we say treatment when ignoring blocks and treatment is test first checks. Treatment here, test materials are significant. And severity of CMD, nothing significant here. And these are the other descriptive statistics that we may need. So you can get the report of this, all this here in the console, Microsoft Word, or your documents, so that you use it later. So for you to do that, you write reports. Yeah, if you want to print your result in a text file, report.augmentedrcpd.bulk. This is what we used. We want to get a report of this. Report.augmentedrcpd.bulk. You write org.bulk is equals to out. Okay, so we want this out, comma. You put the target to put the file.path, the path where you want this report to go. This target file path, temporary directory, you put this, then comma. We want it to go to the temporary directory. Then we give the name we want it to be written in the temporary directory. Temporary directory, comma, you write the name which you want. I decided to call it HMT. You can put yours, but you put it .docx so that it becomes a document. Okay, then we run this. Okay, it's running. So you have to wait to finish running. I don't know why it's taking time. It should take a few minutes. Okay, everything has been executed. Now this is where the path where we get our report here. But if you don't get it, just write temporary directory here like this, then you run. It will give you this up to here. You see this one here is from here. This the same. So and we call our document AGM. So if we really want to, if you want to check this out, you click view first. After clicking view, you make sure that this one is checked. The hidden item, if it was unchecked, you check. After checking, we go to see users HP updater. See, we go to see users HP updater. Then we next updater, then updater local temporary updater local temp local temporary add, and we check this one starting from R, this folder starting with RT SH, finishing with SH, starting with RT and finishing with SH. RT SH, we scroll down. RT SH, it's here. So with RT SH, we open. Then we are going to get our reports here. You can now copy this. You copy it. You take it somewhere. You paste it. So you open it again. You open your document here. Yes, you write this. Here you have your report. Well, report of your ANOVA in your text file. And this is it. Very easy. If you do your augmented design across locations, you may need to know the interaction of your materials with the environment. Because if you look at these ANOVA tables here, this does not provide for you to do analysis to check the performance across locations. You see, it just gives you treatments and blocks. But if you want to see if the significance of a location and the significance of the interaction of a location and a genotype, because you planted your materials in augmented design across locations, you do linear model analysis. You go down, you analyze your interaction using linear model. We have this data here, LM data equals linear model data.csv. We import it. You see, it's the same data, but now arranged differently. Let's view it. It's here. Your location now. We have locations. We have central, blah blah, down here. We have eastern, and we have north, and we have coast. And you have your genotypes. your blocks and your checks and your traits. You see, you have your traits here. Block 1, these are checks, you specify, and these are genotypes. These are checks and these genotypes, same thing. Because we have location, you need to know interaction of location and genotypes, and you want to see if the location was significant. So you run a linear model. What you do is, after doing this, you will see the structure, the data, you run this the structure. These location genotypes checks block should be factors, but now they are characters and integers. We convert them to factors used as dot factor, convert to location, genotype, check and blocks. Write them like this, you run. Convert them at a go. Then we check that to structure. Good. They're factors. Then we run our analysis. You do your linear model. You fix your linear model. We start with first trait. We have 3 traits: dry matter content, severity of cassava mosaic disease, severity of cassava brown streak disease. Very linear model. You put your explanatory variable because it's DMC. You put DMC. You put location, checks, genotype, logs, interaction of checks and location. Of genotype. Sorry, interaction of genotype and location is here. Then you specify your data is data2. You do the same thing for severity.cmd. You do the same. Location, checks, genotype, logs, genotype, interaction, and location. You specify the data. You run all these 3 models like that, like that. So we have a mode of DMC, SCMD, SCBSD. We run ANOVA of those models. Write ANOVA DMC that we got there, ANOVA SCMD, that's severity of CMD, ANOVA severity of CBSD. Here, run all these 3 models to get ANOVA. So here is our ANOVA. There is a response DMC. Response variable. You get your ANOVA. The location if they were significant. Okay. The genotype, the interaction of location and genotype. You come down here, you find the response variable is severity of CMD. The location, if it was significant, it's here. The interaction of location. This we do not get using augmented RSPD. So the same severity of CPSD, location, and the genotype, which is the treatment, and the interaction of location and genotype. So that's how we do this. I hope it was helpful, and thank you very much. If you wish to contact me for more details, you can email me using email there, consultwilfred@gmail.com.